Hi, our lesson now is about chi-squared goodness of fit test and the t-test. Let's start by the chi-squared goodness of fit test. The purpose of the chi-squared goodness of fit test is to test if a data set is uniformly distributed. So my hypothesis now would be H node, which is the null hypothesis. We say that the data follows a uniform distribution or has a uniform distribution, and the alternative hypothesis, or H1, the data does not have a uniform distribution. For the chi-squared goodness of fit test, we have to know the degrees of freedom is equal always to n minus 1. The number of values minus 1. Also, for the chi-squared goodness of fit test, we only need to find out the p-value. Now, in order to reject or not rejecting the null hypothesis, we have to compare the p-value with the significance level. We have to compare p-value with significance level. If the p-value is less than the significance level, then we reject H node. If the p-value is greater than the significance level, then we do not reject H node. Don't reject H node. Let's see an example now. We will be solving a question from the IB Questionbank. The question says, according to a manufacturer's specifications, the colors in each variety pack should be distributed as follows. The color brown, red, green, orange, yellow, and purple. The distribution is 15%, 25%, 20%, 20, 10, and 10. Now, Mr. Slugworth opens a pack of 80 sweets and records the frequency of each color. This is the observed frequency. To investigate if the sample is consistent with manufacturer specifications, Mr. Slugworth conducts a chi-squared goodness of fit test. The test is carried out at 5% significance level. For part C, we need to write down the null hypothesis for this test. So now, for part C, H node is that colors are distributed according to the manufacturer specification. In this case, the alternative hypothesis would be colors are not distributed according to the manufacturer specification. For part D of the question, we need to copy and complete the following table in the answer booklet. So we can complete it here. So the first value, we need to fill in this table with the expected frequencies. The expected frequencies, simply, this value is the percentage. I have 15%. So now, the first value for the brown colors, the brown, the expected would be is equal to the percentage times the total. So for brown colors, the expected value would be 15%, which is 15 over 100, times the total. I have 80 sweets. The total number of sweets are 80. So this would be equal to 15 over 100 times 80. I use my graphical display calculator. 15 over 100 times 80. And this will give me 12. So the expected value for brown eyes is 12. I repeat the same process for red, green, orange, yellow, and purple. The red, the percentage is 25. So I have 25%, which is 25 over 100, times 80. And this will give me 20. The green is 20%, so I have 20 over 100 times 80. This will give me 16. The orange is 20%, so it's the same as the green would be the expected, which is 16. I have the yellow to be 10%, so I have 10 divided by 100 multiplied by the 80, which gives me 8. And the expected value for purple also is 8 because it has 10%. So now we filled in the expected frequency table, and we have the above table is for the observed frequency table. Let's continue for part E. Part E of the question wants the number of degrees of freedom. So now, for part E, the degrees of freedom simply equal to n minus 1, which are the number of observations minus 1. I have 6 observations, so it will be 6 minus 1, and the degrees of freedom is simply equal to 5. Part F, we want to find the p-value for this test. In order to find the p-value, we need to use our graphical display calculator. we start our graphical display calculator. We go to menu and we go to statistics. First, we have to fill in the last one with the observed frequency. I fill in the observed frequency in my calculator in list 1, and I fill the expected frequency in list 2. Now in my GDC, I start filling. I have 10, 20, 16, 18, 12, and 4. Let's fill list 2. It's 12, 20, 16, 16, 8, and 8. Now we go to test, we go to chi, and we start GOF. We press on the GOF, which is the goodness of fit test. We have the observed frequency, we filled it in list 1, and the expected frequency in list 2, and the degrees of freedom is equal to 5. Then we go to execute. We find that the p-value is equal to 0.469. So the p-value is simply equal to 0.469. Let's do part G now. We need to state the conclusion of the test. We have to give a reason for our answer. We have to compare the p-value with the significance level. We have the significance level is 5%, which means it is 0.05. I have to compare the 0.469 with the 0.05. So now I have the 0.469 is greater than the 0.05. Since the p-value is greater than the significance level, we have, according to what we discussed in the beginning of this lesson, if the p-value is greater, we do not reject each node. Since the p-value is greater, we do not reject each node, which means that we can conclude that colors are distributed according to the manufacturer specification. By this, we could solve our question.